Okay, this video is going to be about how to conduct factorial ANOVA using JASP. But before we get into JASP, I want to talk a little bit about finding the data that you want to use. I think this project, more than any other, is kind of challenging to find the data for, just because you have to find not one but two independent variables that overlap, and that they overlap in such a way that you can have maybe 10 observations in all possible combinations of the independent variables. What I would recommend doing is starting by thinking about a dependent variable, something that you could count or measure, and that if you Googled it, it would probably show up. When I was thinking about this first yesterday, I went outside and I ran into my neighbor, who also teaches here, and he was walking his dog, and we got to talking about how it seems like there's dogs everywhere now, like more than ever before. And so since I had been thinking about this, I thought that, well, maybe I could study dog ownership. How do you turn that into a factorial ANOVA, though? You need to be able to divide it into two or more groups one way, and then to make it factorial, you have to divide those into two or more groups. Just was trying this out. I typed in to Google dogs per capita by state. Now what that'll let me do is find out a dependent variable, dogs per capita, how many dogs per person, and a way of dividing things up. States are ways that we can divide things up. So when I went to that, I found that, sure enough, they have this set up on a state-by-state way. So now, this is the top 10, and top 10 most pet owning and the top 10 fewest owning. I don't want to do something like that because obviously those are going to be different. What I might be able to do, though, is take a look at these states and divide them by region. I can do the northern United States versus southern United States as one variable, and then the eastern and the western United States is another variable. And that would give me 4 quadrants in the United States, and I can compare north to south, east to west, and then look for an interaction between the two. And I think I have enough data here to where I could do that. So if I looked a little bit more closely, I could probably find something there. And that's just adorable. Look at that. Another thing that you can do is just go to a website where you know there's a lot of data. Several of you have gone to Rotten Tomatoes and in the past, and you know that if you go to Rotten Tomatoes, you're going to find tons of data. A couple ways you divide things up here. If you look at this, you see that there are a dependent variable right here, which is the tomato meter or thermometer. And then you can say, well, is there like a difference between comedy and horror, comedy and action, something like that, and use that as a way of dividing things up. And then you just need to think of one other way to divide things up. You could say, for example, movies in the 2000s versus the 2000 teens, and get 10 movies from each. So you can compare genre and compare decade. Something like that would work. In all the cases that I've mentioned so far, what I've been talking about have been independent samples. Now, it is possible to do dependent samples, and I think some of you did dependent samples for the one-way ANOVA. It gets a little bit more complicated, but if you want to do that, just send me an email, and I can make a video showing you how to do that. It's not that hard to do. I just don't want to pile it on top of this if people aren't interested in doing that. So probably stick with independent samples. All right, now I'm going to show you how to do one of these using our Stroop test example. I'm going to pause just a second while I can get set up. Okay, I believe everybody remembers the factorial Stroop test that I set up. In that Stroop test, we had a 2x2. We had the Stroop condition with 2 colors. That means red and blue. We had the Stroop condition with 6 different colors. It's red, orange, green, yellow, pink. Blue was supposed to be in there, but it's not. And then we have the block condition with 6 colors, block condition with 2 colors. So this is a 2 block by 2 colors analysis of variance, or 2 format, 2 colors. I have to fix that. That's driving me crazy. There we go. Okay, so I've got my data in a table. I find that it helps to write all your data down before going to Excel with it. And what I'm going to do is transfer this data into Excel. In Excel, what I want to do is create a column for my dependent variable. And that's the number of seconds it takes someone to do the test. I'm going to create another column for an independent variable. So that's format. That shows whether or not whether the person did the block test or the Stroop test. And then the colors. They can do 2 colors or 6 colors. Now, what this allows me to do is put each person's score in. First person got a 9.3. And then the next 2 columns I indicate whether the person was in blocks or Stroop. I'm actually going to type in the word block. And whether there were 2 colors or 6 colors. That was 2. I think last time I asked you guys to type in 0s and 1s, but you can actually type in the words if you want. That's a new feature. Okay, so that is a person in the block condition with 2 colors. I can actually just kind of run down the list and type in all of those numbers. Block, 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 block. 2, 2, 2, 2. It doesn't matter what order you do this in. Okay, I can scramble them up, whatever. I could put seconds last, format first, colors first, whatever up here. It doesn't matter as long as I have 1 person per row and I get their scores identified with the correct group. That's the next 4. This is the Stroop condition. With 2 colors. Whoops, 11.1, 10.4, 9.7, 10.1. And that is block, 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 block. And 6 colors. I'll go ahead and do that because I know it's going to be 6. And that's going to be Stroop. 17, 20.1, 13.4, 15.5, 16.9. There we go. So I've got them all set up, and I'm going to save them, and I'll be right back. Alright, so you can see my data pulled up here, and I've got all my data. It's all correctly labeled. Okay. Alright, so what I need to do is an ANOVA, and because I'm doing a independent samples ANOVA, I just go here with the plain one. And my dependent variable is seconds and the fixed factors. Remember, factors just means independent variable. That's format and colors. Now, those can go in either order, it doesn't matter. I'm going to want descriptive statistics. I want the effect sizes. Remember, we use partial eta squared here. Get this a little bit bigger so it fits in the window. And that's most of what we need here. You see that it puts it out in the same source table format. There's format significant with a partial eta squared of 0.636. Colors significant, eta squared of 0.570. And then this is the interaction format by colors. And that's also significant with a partial eta squared of 0.364. This guy right here called residuals, that is what we call in class, we call that within. Residuals and within, those are just synonyms. We'll find out what residuals means next week. Now there's some descriptive statistics there, and you can use those if you want to write about that in your write-up. Coming down here, I don't need post hoc tests because I only have two levels to each independent variable. I do want some descriptive plots. Now I get to choose which one goes where. I'm going to put format on the horizontal axis and colors as separate lines, and I can do that the other way around if I prefer. In fact, if you want, you can do both and see which one you like best. You can do confidence intervals here or standard error. I'm going to do confidence intervals first, see what that looks like. I think that looks good. And you can see here this interaction where the lines slope at different angles. And they'd intersect about right here. So they're non-parallel and significant. All right, so that's what you would need right there. If you want to put this in your document, you just go right there and hit copy, and you can paste that directly into Microsoft Word or Google Docs. And you can do that up there as well. Last time, some people did not include the output, so it's important to include the output so I can make sure that you're getting things right. So please try to do that. Yeah, I think that's about all you need to know. Again, if when you do things like put these in, it doesn't matter what order you put it in. I put in format and colors. You could do colors and format. Down here I had format and colors. You could have colors and format. It doesn't matter. So you can actually try it the other way if you want. See what that looks like. That's what it looks like. All right, I'd say have fun with the task. If you do wind up having a paired sample or two paired samples, let me know and I can help you through that. Otherwise, I think independent samples will be fine.